What's up, everyone? Welcome back. My name is Aaron Hunter. I am a senior technical trainer with AWS training certification. And today we're going to talk about Amazon Aurora. With me, we have
Brian Terry, and I'm a senior developer advocate on the CloudFormation team, and super excited to talk about this next feature of serverless. So,
it's so awesome. Serverless V2. There's a second version
serverless
now.
feature.
So
Yeah.
I'm Aaron. This is Brian, and down here we have.
I'm Jared Persinger. I am a database specialist solutions architect, and I'm based out of not so sunny Tacoma, Washington.
Oh, we're doing locations. Okay, I'm based out
Yeah.
of really hot Frisco, Texas. It's actually we're in a cool front. It's only 90 degrees.
I think I'm in hot Atlanta, and it's only 106 degrees
here. Hot Atlanta.
Hot Atlanta.
I'll take
cloudy
Tacoma.
All right, cool. So, Jared, today we're going to talk about Amazon Aurora Serverless V2. What is that all about?
Yeah, sure. So Serverless V2 is actually really exciting. It's one of our newer services. It is not to be confused with V1. It's actually completely different, built from the ground up. It just became generally available on April 21st, in fact. So very new service, hot off the press. Let's get into it.
And we have chat moderators. So if anyone has questions, please feel free to type those questions in the chat. We're streaming to multiple locations: LinkedIn, YouTube, Twitch, Twitter, all the stuff, all the places.
Awesome. So as Dustin talked about in the last session, Serverless V2 is built on Amazon Aurora. So I'll kind of keep touching on a lot of the things that he discussed during that. But Aurora is, of course, our MySQL and PostgreSQL compatible relational database. You get all of these great features that you see here, and serverless is built on top of that. So it's already a great service, the fastest growing service, in fact, in the history of AWS. So we started with a great foundation and built something great on top of it. And another thing that Dustin discussed quite a bit was that storage layer. And that storage layer is really dynamic. And what we wanted to do was try to match that dynamic storage layer with a equally dynamic compute layer. So again, kind of just to recap, we have that storage layer that can grow and shrink based upon your needs up to 128 terabytes. You have 6 copies of your data stored across 3 availability zones. Ultra low latency there, about less than 10 milliseconds. It's purpose built, all these great things that go on with that storage layer. And then on top of that, we had instances where you kind of had to manually adjust the size of those based on your workload. If you were going to get something like a sale or something going on, a flash sale, you would have to actually go in there and manually increase the size of that instance to meet that demand. And that's what Serverless V2 is trying to get rid of. So you can see here, I have these 3 charts. They're all different versions of spiky workloads. You can kind of see they go in varying degrees of predictability from left to right. You have on the left there, you can see there's kind of a pattern there, right? But something to point out with all of these is the distance between that peak and the average. So you want to provision for peak, because if you have insufficient capacity, you're kind of getting a degraded experience for your customers. But then again, if you provision for the peak, it's also can be really expensive. So how do we find some middle ground there? You also have some options to, create some functions or some scripts that can scale these on a schedule, or look for indicators that can scale them as well. But that can be difficult. It requires a lot of expertise, and it usually requires some downtime as well. So Serverless V2 comes in, it's on demand, like many of the services that AWS offers. It's pay per use. And it's going to scale based on the needs of the application, rather than trying to predict the needs of the application. It will scale with it. So scales instantly. It will support the most demanding applications. And one of the best parts, we talk about this a lot, is undifferentiated heavy lifting. It removes that undifferentiated heavy lifting from people like your DBAs, database administrators, or engineers. So they can be freed up to do things that are probably arguably more fun than provisioning database instances.
More fun, like spending time with their family and friends.
Yeah, exactly. Or, hey, improving the application, innovating for the company, all these great things. Yeah. But yeah, that's up to them. So let's talk about some use cases, right? We have typically with like a multi-tenant application where you have maybe like a software as a service here on the left side, and you want each customer to have their own tenancy in there. We want some data isolation. Each customer gets their own database, right? Well, we can stuff all of those into one database instance, but then we have to again provision that database instance to meet the needs of the noisiest neighbor there. You may have one tenant there that is just using a lot of resources, and you got to create an instance that can handle all that. And that's one of the things that kind of goes away when you have a more dynamic instance like serverless v2. And then kind of similar to that is, especially in SMB, we have a lot of customers moving towards microservices and things like that. Then that starts to increase their ability to create applications. So we start to get hundreds, thousands of applications even. And they may be backed by one or more databases, but the actual use of those applications can vary. So this gives the ability to, again, flex that database capacity to be able to meet the needs of either the most quiet application or the most noisy application. And we have another one here where this is kind of an interesting one where customers will actually, at the application layer, find a way to do some right scaling to get better throughput. But typically in the past, when you did something like this, you had to determine how many nodes you would need, the size of those nodes, all of that fun stuff. And if you didn't say all of those nodes get filled up, when you need to add nodes, that's going to require like a resharding operation, and you're going to actually have to go in there and have some downtime associated with that. And that can be pretty painful. I'm sure the database administrators and engineers out there would prefer to stay away from resharding operations. And then one of the last ones we have here, and I think this is also pretty applicable to our SMB customers, is if you have a new application, it's like pre-launch, you may not know really what the demand is going to be for that application. Mm-hmm. So this is kind of one of the things we do with DynamoDB as well. We set it for on demand, and then when you figure out about what kind of resources you're going to be using, you switch over to provision. So the same is very similar with Aurora Serverless v2. You can use serverless instances to kind of gauge what the demand is going to be for your application. And then once you understand that, maybe you want to switch over to something like a provisioned instance that can be more cost effective in some situations, depending upon what the variability of the load is. I know in one of the future sessions, we're going to cover cost optimization. So I won't hammer down on that too much, but V2 can be a very effective way to manage costs. So when we talk about our demanding workloads, right, what do they need? We need instant and non-disruptive scaling. And that's one of the things that serverless V2 gives us. So I said before, not to be confused with V1, right? Well, V1, there was a disruption when we had to scale. And there was a bit of a warm-up period that we had to have before we could actually scale. So
customers had to account for that warm-up period in terms of reacting to that capacity change.
That's exactly right. That's exactly right. And there would be some potential downtime in there as well. So serverless V2 gives us instant and non-disruptive scaling. And then
Whoa, that's kind of amazing. You just kind of glossed over that. So like when it scales, it's instantly no downtime for this.
Yeah, it's very quick. And we will, in one of the future slides here, I'll talk about how you can even speed that up a little bit. There will be ways to adjust that depending upon the capacity range that you have provisioned. So yeah, I'll discuss that in a future slide. But yeah, it's very interesting stuff.
That's super amazing. I think I just think it's amazing. I mean, to be able to just scale these databases on serverless and there's no downtime, I think it's awesome.
It really is. I mean, we're all excited about it. I know all of the solutions architects like myself are super excited about it. I mean, guys are spending time tinkering around in the console and testing out serverless V2 instances, and we're having discussions about it week to week. So we are learning, just really at the same time as our customers, because this is such a new service. So it's great. It's good stuff.
Cool.
So Another aspect of serverless V2 is the fact that it's so fine-grained and predictable. It will actually scale up in half increments. So what we use is something called Aurora capacity units, and I'll get into this in a little bit, but that's the way that we sort of measure capacity on serverless instance types. And with serverless V2, you actually scale in half ACU increments. Whereas before on serverless V1, you essentially had to double capacity every time you scaled. So say you had 16 gigabytes of memory provisioned and you needed 20 gigabytes to meet the needs of your workload. Well, it wouldn't scale up to 20, it would actually scale up to 32. So you're getting a little bit of unneeded capacity there. Whereas
wasted space
V2,
and more cost too, I'm sure.
Exactly right. Exactly right. And so serverless V2, every half ACU is 1 gigabyte. So if you think about it like that, 1 gigabyte of memory scaling. And then in the third block here, this is kind of, again, carryover from Aurora. You're getting the same great high availability with read replicas. That's a common question. Can I do read replicas with serverless V2? And you're getting the great disaster recovery capability with things like global database. And you're getting all of the other enhanced capabilities that serverless V2 offers with that great storage layer that Dustin gave us a deep dive on. So again, scales in place in under a second by adding more resources. There is no impact to the database, even the most demanding of databases. We do go and use a process of rotating these instances because, right, we say it's serverless. However, of course, it does end up on hardware somewhere at some point. And we want to make sure we're not hammering down on one piece of hardware due to one of those particularly demanding customers. So we make sure we rotate that for heat management. And then another aspect of scaling that often kind of doesn't get discussed is what about like background processes and things like that? How do we make those happen on a serverless instance? Well, the instance can actually just go ahead and scale itself up, conduct those background processes like buffer pools and maintaining connections and cache warming, and then scale back down when that's complete. So let's talk a bit more about buffer pools. I know that Dustin.
And before we do that, there was a question in the chat, and one of the chat moderators already responded to it, but I do want to bring it up, and if you don't mind talking about it quickly, the question was, what if we delete some data? Let me show it on the screen here. What if we delete some data, but we have a database backup 12 hours before? How can we revive data between this time?
Yeah, so you can use the same processes that you would use on Aurora. You can use you can restore a snapshot, of course, back to that period of time. And there are a few other methods. I'm not sure what was in the chat. Can't see the chat from here, but does that answer the question? I think so.
Yeah, I think so. And for those who maybe are catching the recording on a different platform, I'll throw the answer up here. It's going to take up a lot of screen space, so I might actually go away. Brian might go away. Jared, I'm sorry, you're going to get hidden. And there we go. So thank you so much. Hey, I'm still here. What's up? All right, pause it, read it, and then we'll go ahead and resume.
Yeah.
Great.
Yeah. And I just want to show this one because I think it's cool. Because I thought it was cool.
Yeah.
Is that this is awesome.
It's so awesome.
All right. So yeah, let's get into buffer pool resizing. Dustin talked a bit about buffers. This is one of the ways, again, that we maintain our cost controls on Aurora and Aurora Serverless. You want to be reading from the buffer pool as often as possible, right? You want that buffer cache hit ratio that's in your CloudWatch metrics to be a nice straight line at 100% if you can. That way you're reducing cost, you're not incurring IO costs by reaching down to that storage layer. But, you know, buffer pools are a function of memory, right? So how do we make sure that we have enough buffer pool allocated? And then how do we shrink that buffer pool when we're doing these scale up and scale down operations? Well, we use something called we use two algorithms, the least frequently used and least recently used algorithms. And I know this is a bit complicated, so I have a nice little diagram here for you. So you can see here outlined in the dotted black line, that's kind of the memory that's currently allocated to our cluster, right? So say we have 1 ACU, that means we have 2 gigabytes of memory allocated. And we can see within that, we have our buffer pool, which is the kind of purplish, bluish background there. And then inside of that, all of these rectangles from gray on the left to red on the right, those are our pages that are currently in buffer. And then you have the little line, of course, there that depicts the access frequency. The gray pages are the colder ones, and the pages on the right, the red ones, are hotter.
It's kind of hard for me to see the purple. So the buffer pool is anything inside the dashed lines, right?
It's actually, there's a small background behind the pages there. You should see it adjust here in a minute. I got some nifty animations for you, so you'll see it kind of shrink.
Cool.
Yeah,
Looking forward to that.
Get ready.
All right.
And then so then we have the storage volume down below, and again, this is that awesome storage layer that Dustin talked about a lot in the last presentation. But this is that really unique storage layer that's unique to Aurora. But so let's say we're doing some reads here, right? And we're reading this page. This is a hot page. So this is a really interesting page to either our application or our customers. For some reason, that one's really getting after it.
Index.html.
We have some additional room here, though, right? We've got some empty space there, and inside the buffer pool, we got some additional memory to work with. So let's expand that buffer so that we're giving the customers the best chance of hitting the buffer and not having to reach down to that storage layer. So let's slide these cold pages off to the left a little bit, open up some space here, and we'll inject a couple of pages that we think are more likely to be read by the application. So we've got those in there, and really this is just showing how you expand the buffer pool. So maybe we scaled up to 2 ACUs. We've got more memory allocated, so now we have a bigger buffer, more pages in the buffer, better cost optimization, better performance as well.
Awesome, thank you. And you didn't lie; you had some really cool animations going on there.
Oh, I'm not done.
They were moving around and flying in and out. Yeah.
So what about when we've got to scale back down, right? So workload is going down. We don't need as many resources anymore. How do we scale this back down? Well, we use those algorithms, and we look at these cold pages, and we're like, hey, we can get rid of these cold pages. They're not being accessed. So we evict those cold pages. We then shrink the buffer. You see that background kind of shifted. I don't know. It might be tough to see. It's pretty light color, but it shrank inside of there. And now we shrink memory. So you can see that the dotted line kind of goes back around that. And we've essentially scaled down at this point to a smaller buffer pool.
That is really cool. Yeah, thank you. So there's actually one question in the chat. Let me see if I can bring it up if we have time. Do we have time for a question, Jared?
Sure.
Okay. So the question here is, what do you think about using serverless database in a dev account and not in prod? Will that help us save any money?
It certainly can. Yeah, if you want to keep the database up and running, you can choose, and I'll get into this in a bit about the kind of the range of capacity that you can choose. You could choose anywhere between half an ACU all the way up to 128 ACUs. So if you want to keep the database up and running, and maybe you're not going to be accessing it for a couple of days at a time, it can scale all the way down to half an ACU. And yeah, you could potentially, for sure, save some costs that way.
So in the end, it doesn't matter if it's a prod or dev account, you can still use serverless, help to kind of create this proof of concept and also figure out how the application works and how the database works in tandem with each other.
Absolutely. And that kind of goes back to that last use case that I showed there. If you're sort of unsure about the capacity, serverless is a great use case to kind of be able to see what the capacity could be and move to provision after that if you want to, if you have an expected workload there.
Adding a single or a half ACU.
Yeah, absolutely.
Cool.
Okay, so let's talk a bit more about Aurora capacity units. I know you were all waiting. So we got this is kind of just the way that we describe a combination of CPU, networking, and memory. This is the way we measure capacity. One ACU comes with 2 gigabytes of memory. And then if you're trying to figure out sort of like how many vCPUs am I getting, how much networking am I getting, you can look at the similar Aurora instances. So if you have an Aurora instance with 2 gigabytes, you can look at the vCPUs and the networking that kind of comes with that, and it's going to be very similar. The reason we don't give a specific number is because that can kind of fluctuate a little bit up and down depending upon the needs of your application and the needs of the background system. So but you start at half an ACU, as I mentioned, and you can go all the way up to 128 ACUs. So from 1 gigabyte of memory all the way up to 256 gigabytes of memory per instance. And then you can scale very finely in just those half ACU increments. So you're never going to just blow way past what you actually need, and another way to really optimize costs. Also, sustainability is a big factor here as well, and I think we're going to touch upon that in a later discussion. But if you're not using unnecessary amounts of resources, then you're also not using unnecessary amounts of energy. So something to consider there as well. Since that is our newest pillar of the well-architected framework, I figured I'd touch on that a bit.
Absolutely.
So scale up rate, right? We talked about this a little bit. It is going to start scaling instantly. However, the time that it takes to get to maximum can vary. And that is going to be proportional to the current capacity. So if you have 0.5 ACUs as your minimum capacity and 128 ACUs as your maximum capacity, it's going to take a lot longer to scale up to 128 than it would be if you had, say, 16 ACUs as your minimum and 128 as your maximum. So the more narrow the range, the faster it will scale up to the maximum. And then sort of the triggers that we use to initiate that scaling are metrics surrounding CPU, memory, and network, as you could probably imagine.
Interesting.
And so a lot of conversations with customers currently are around configuring capacity. Configuring your maximum capacity can be a little bit easier because you can, especially if you're already running in Aurora, you can take a look at kind of the amount of CPU load that's typically on your database, and you can find a nice maximum capacity in there. But people often wonder about, how do I configure this minimum capacity? Do I just put it to 0.5 and let it go as low as it'll go? And that's not always the case. So we can think of the maximum and minimum capacity in two kind of unique ways. So minimum capacity, you can use that sort of as a way to adjust your scaling rate. So if you feel like you're not scaling fast enough, you can move up that scaling rate or move up that minimum capacity to increase that scaling rate. And then as far as maximum capacity goes, we use that as a budget control. So I have a 14-year-old son. He has his own debit card now, as terrifying as that is. But we're able to put a spending limit on it, which is really nice. So I don't end up with like a bill for 1,000 Fortnite V-Bucks or something.
You're going to throttle your son's spending.
Yeah, exactly. So it's kind of the same thing. We're setting that maximum capacity so that we make sure that we're never spending more than we expect. And there are a couple of other things to consider. So for instance, Performance Insights, which is a great tool for monitoring our SQL, things like top SQL, SQL weights, that requires at least 2 ACUs. So that's one way to kind of configure that bottom threshold. So yeah, that's an interesting conversation to have with customers, and one that we have a lot.
And then to give you 2 ACUs, that would give you, if I remember my math, and if I carry the 1 over, what is it, 4 gigabytes of additional compute?
That's correct. And I like that
Okay.
you use the gigabytes. Very exact.
I saw the I there.
Nice.
Yeah. So a couple of other two really important things to consider here are the versions that you're currently on. So if you're on provisioned Aurora and you're considering using Aurora Serverless V2 instances, then you need to be on at least MySQL 8.0 or Aurora Postgres 13. As of last week, Postgres SQL 14 is now available on V2. So that is one major thing to consider before making a move over to serverless is that it's only available on MySQL 8 and Postgres 13. So let's do a quick demo here. Let's create a serverless V2 database. Let's just get into it.
Super exciting. Let's see the demo.
Demos are amazing. Yeah.
So we've got our RDS console here, right? We're in the AWS console. We're looking at the relational database service console. This is where we launch all of our databases from with a nice graphical user interface. You can see we have some clusters already provisioned in here, but what we want to do is we want to create an all-new serverless V2 cluster. So let's go over here to create database. Takes us to the screen where we're used to launching our databases from. We'll do a standard create. Make sure you're using Amazon Aurora. And then we can choose our edition, or either MySQL or Postgres. A new filter that we have now here is the ability to filter versions that support serverless V2. So that MySQL 8.0 and Postgres 13 plus. We'll switch over, toggle between the two versions. We'll go with the Postgres version. We'll go with production. Let's change the name of the cluster though, so we can identify this as our serverless cluster. We'll keep the regular username, we'll let it auto-generate a password, and now is where it gets really interesting, is the instance configuration. So you can see we have a new instance class here, serverless. We're going to choose the serverless V2. This is where we set our minimum and maximum ACUs for capacity. We'll set it at the lowest and then at 64 for the highest. Let's not create a replica right now, and we'll go ahead and launch this. So now we can see we have a cluster provision here. It's in Asia Pacific South 1. We have one instance. We'll do some refreshing here and get this thing up. We can also see in the bottom line there, we have, it says reader instance. We'll switch over once it's creating, but it's serverless V2 with half an ACU as the minimum capacity and 64 ACUs as the maximum capacity. Now, what if we want to get in there?
That, because there's actually a question in the chat that was asking that same exact. So Justin did answer it, but it's from half to 128, right?
Correct. The full range is 0.5 to 128. And so, what if we want to modify this? We set 0.5. We realize, well, that's too low, or maybe we've got like a flash sale coming up, and we want to make sure that we're meeting demand for that. Let's go ahead and just click the cluster, then click modify. We go in here, we change the minimum ACU capacity, turn off this deletion protection, and then we'll apply that immediately to the cluster. And through the magic of video, we have fast forwarded to the point where we have our serverless instance provisioned with a minimum of 4 ACUs and a maximum of 64 ACUs. So that's the basics of creating a serverless cluster with one instance. And if you wanted to do this in the AWS command line interface, a lot of people like to do this programmatically so that they can automate things. It's very similar to the way that it's done with an Aurora cluster, only you'll just see this little boxed area on the right. We're just adding a line that gives us that minimum and maximum capacity for our ACUs.
Yeah, you can do this with infrastructure as code too, right? Like CloudFormation.
Yes, for sure. Actually, you cannot provision serverless V2 cluster with CloudFormation just yet.
Oh, wait, hold on. I'm going to challenge that. So you can use a custom Lambda function though, because it's all just an API call.
There you go. There seems like there's always a workaround, right? Whenever you find
yeah, or custom resource type. Yeah,
that's right.
Yeah.
And so with creating instances as well, very similar. But you'll see on the left, they provisioned an R6 Graviton 2 instance. And then on the right, it's just called a db.serverless. And then, of course, that will scale based upon the ACU range that you set on the cluster. So that's an important thing to point out. ACU range is set on the cluster and not on the instance itself. So every instance on the cluster will have the same ACU range.
And you can change that after you've launched your cluster.
Indeed, you can change it anytime.
So if you happen to, I don't want to say make a mistake, but have a configuration mishap, then you can change that after the fact. Okay.
Sure. And again, as a best practice, keep it keep it at a kind of a baseline. Then if you're expecting some increases in traffic, you can increase that minimum to kind of warm things up a bit. All right,
And that actually
so
comes back to a question that was in the chat. So root user is asking, I'll throw it on the screen here. Is it okay to use Aurora Serverless v2 for prod environments?
absolutely. So you will find very few differences between Aurora Provision and Aurora Serverless. Actually, the way that I've heard it described best is think of Serverless v2 as just a new Aurora instance type. The clusters are still the same. The storage layer is the same. You can mix provisioned and serverless cluster or serverless instances within a cluster. So if you have pretty predictable write workloads, for instance, you could have a provisioned writer, and then you could have, maybe have unpredictable read workloads. You could have an entire fleet, up to 15 Aurora Serverless v2 reader instances in that same region.
Awesome, thank you. And actually, we talked about making these changes, and what if you misconfigure the ACU when you're first launching your cluster? Do we have time for one more question?
Sure.
Okay, so David is asking, is there any downtime when making these changes?
The only downtime is when you reconfigure the maximum. There will be a reboot of the instance required to reconfigure the maximum ACU range, but no downtime with reconfiguring the minimum.
Awesome, thank you. We'll save more questions for a later time. So,
great.
Yes.
Okay, well, let's get into another demo here. So let's see how generating a load and simulating a flash sale would work on Aurora Serverless v2. So we got a load generator. It's firing up a bunch of these Lambda functions, which if you're unfamiliar with Lambda, it's like a serverless compute service that AWS provides. And it's reaching back to an Aurora Serverless v2 database. As that load increases, those Lambda functions increase in scale, and the Serverless v2 database can also increase in scale. So how does this work? We have a Jupyter notebook here that actually creates the load. Go ahead and run this. And then we'll switch over to our CloudWatch metrics. And we can see the green line is our order count, and the orange line is the serverless database capacity of our database. And you can see as the amount of orders peak up, they kind of jump very quickly up to that 5 line there, around 2,000 orders. And then we get 5 ACUs with that. And then it generally just stays in line with the load, and it kind of plateaus here around 10 ACUs. And you can see this is happening over a period of about 7 minutes or so. But one thing that's important to note here is you can see that now the demand has dropped off, right? We've gone back to 0 with demand, but we've kept a little bit of resources running just in case that demand jumps back up. So for about 5 minutes or so, we maintain some capacity to meet the need of any additional jumps in orders. All right, so now we can get a little bit more into when I was talking about ways that you can add read replicas and things like that. So as I said, 15 read replicas can act as failover targets. Something really important to note here is that failover tiers 0 and 1 will scale with the writer. So whether that is a provision writer or a serverless writer, any reader that is in failover tier 0 or 1 will scale and basically stay pegged with that writer, just so it's ready to go in the event of a failover. We want you to have that really fast failover. So we want to make sure that failover target is ramped up and ready to go. But yeah, by adding just multi-AZ as with Aurora, that's gonna enable you to get to an uptime of 4 nines there. So yeah, and as I said, they all inherit the capacity from the cluster. So so kind of how can we do some interesting things here? How can we is everything going to going to scale together? How can we separate things? So we have an application here, right? It connects to our cluster endpoint. So you have 3 different types of endpoints. You have a cluster endpoint, which connects to your writer. And then you have reader endpoints that can connect to your readers. And if that's just the standard reader endpoint, it will connect to all the readers. Or you also have custom endpoints that you can connect to particular readers. So you'll see how that kind of comes into play here. So the cluster endpoint connects to our writer. The writer begins to scale up to meet the need. And then you can also see that tier 1 reader is also starting to scale as well. And they've both scaled up to meet the need of the application. So we have this reporting app, right? It's got a custom endpoint that goes to these tier 14 and 15 readers. We can actually have those tier 14 and 15 readers scale up independently as well. So you're seeing that we're not wasting unnecessary resources by scaling the writer or the reader that are in tiers 0 and 1. Let's do another demo here. You can see we have a cluster here with a writer and a reader. Those are both serverless. Let's go ahead and just roll this back a bit here. Let's go ahead and add a reader to this. Let's see how easy this is. So we're going to add another reader. We're going to call it Flash03. It'll be serverless v2. So you can see here, we can't adjust the minimum and maximum capacity because that's at the cluster level. We'll make this tier 15 because we don't want it to scale with our primary, our writer and our primary reader instance. And then we'll just scroll down. We'll add that reader. And we'll get that reader. We'll give it a couple of recycles here, refreshes. So now we have our a writer with 2 readers. One of the readers is a tier 1 or tier 0, and the other is a tier 15, as we showed. So let's get back to our flash sale, right? So we've got our writer is the blue line. It's scaling up to meet the demands of the flash sale, and then you can also see the tier 0 or 1 reader, which is the orange line of flash 2. It's scaling up as well. But now we have flash 3. It's staying down and controlling costs by keeping the capacity at a minimum. There is a little bit of a bump there because it's doing background things like vacuuming, or if you're running cluster cache management in Postgres, something like that. Any background processes that it actually needs compute resources for, it can scale up on its own to do that. So and then you can see they kind of scale back down together. But generally, the tiers 0 and 1 readers will scale with your writer. So that's an important thing to keep note of. And if you were to have, say, a provision instance as your writer and a serverless reader, then the reader will stay up in the same. So it will go all the way up to 128 ACUs if the provision reader is provision with more resources than that, if that makes sense. So another great feature that we have with regular Aurora, with serverless v2, we also have Aurora global databases. So kind of the same thing. Dustin talked about this a little bit. This is great for your disaster recovery plan. We have our primary in US East 1, and we're as we're coming along, actually a lot of SMB customers have asked me about this recently, is how can we improve our DR capability, even in the unlikely event of a full region outage or something like that. And the way we do that is through global database. So we are able to have a secondary cluster in a secondary region. So for example, this is US West 2. If something happens with our primary, we're able to fail over to that secondary. There are a couple different types of failover. I won't go into all that, but we have generally, like I said, same capability to do global failover that you do with provision.
And here it's showing. So at first you were showing just in the U.S. So you have one region, let's say US East 1, another region, let's say US East 2 or West 2. And then now you're showing across different countries even. So the customers can select the global database replication.
That's exactly right. So you can choose up to 5 secondary regions. So you can have a primary there in US East 1. You could have a secondary in US West 2, a secondary in Europe, a secondary in Australia, up to 5 secondary regions with up to 90 read replicas there.
Because I know that's probably important for some customers who have compliance requirements where they can only have their data residency in certain areas.
Yes. So one way that serverless can kind of complement that, right, is say we have our primary region here, our applications pointing to it. We have provisioned writer and reader in there because we have a pretty expected workload. Like nothing crazy happens, not very spiky. Things kind of go very well day to day, but things don't always go well, right? So we have a secondary region just in case. What we can do is we can put serverless instances over there. We can have 2 serverless readers over there. Those can scale themselves down because they're not really getting a lot of work from the application. But then in the event of a failover, we can repoint the application to the secondary region. We can promote that reader to a writer, and they start scaling up to meet the demand of the application. So that's one way to save costs in your secondary region. So
while still at the same time ensuring that there's high availability because you have this automatic failover option too.
That's exactly right. And you're basically duplicating the same cluster that you have in your primary region because you already have the 2 instances over there, and one of them promotes itself to a writer upon the failover. So and then you automatically have your multi-region high availability there.
Awesome, thank you.
Multi-AZ, excuse me. All right, so let's look at adding a region. How easy is that? So we have Asia Pacific South. We're in 2 different availability zones there, C and B. Let's click on the cluster and let's add a region. So we'll add a new identifier for the global database, call it orders global. We'll add US East Ohio, that's US East 2. And we'll, again, serverless instance type. We want 4 ACUs as a minimum and 128 for our maximum. We won't create a replica. Just go through and make sure the rest of our settings match our primary cluster.
Is there ever a time that you wouldn't create the maximum being 128?
Yeah, so I talked about that previously. So it would be like I kind of describe the maximum as a pause this. I describe the maximum as a, sort of the knob you turn to control costs, right? If you don't want to spend 128 ACUs worth of resources, then you can crank that down. We really leave that up to the customer to decide what their performance needs are going to be, and then balance that with cost.
The cost control mechanism to help throttle your 14-year-old's spending.
Exactly right. Yeah. So
Jared, if you have time for another question, we have one that just popped in. Like, what is the difference between the Aurora global DB tables and cross-region read replicas?
The difference between Aurora global tables is a DynamoDB feature. Aurora global database is an actual. You actually have your data asynchronously replicated to that secondary region. So that same storage layer that you're seeing there in Aurora, that is then asynchronously replicated over to that secondary region. So the data is already there and ready to go. So I'm sure Dustin touched on just the simplicity of just attaching an instance then to that storage layer and how fast that can be for adding instances or things like failover. And then the second part of that question was it cross-region snapshots?
Oh yes, cross-region read replicas.
Oh, cross-region read replicas. So it's so we're kind of talking about RDS with cross-region read replicas.
Another one. She meant a global database. So here is it. So I meant Aurora global database.
Oh yeah. So Yeah, Aurora Global Database is just what we talked about, and that's kind of how you're going to get your cross-region read replicas. You're actually able to. That's another aspect of global database that I didn't mention. You can actually point your customers in that secondary region to those readers in that secondary region as well. If you want to reduce latency or something like that for customers around the world, that's another fantastic option with global database. So that's kind of how that all works in Aurora. So you can see here now we have our global cluster created. So we have a global database cluster now. It has 2 regions in it with 2 clusters. We have one in Asia Pacific South and another in US East 2. This one is actually, our primary is actually provision instances with Aurora. And then our secondary is a serverless instance, because we're going to just kind of use that as more of a warm standby rather than an active instance. So let's keep this going here. And we'll be able to see, this typically takes, it depends on the amount of data in the system, the amount of, the size of the instances, how long this takes to actually create. But adding something like a reader to an existing cluster, usually about 10 to 15 minutes in my experience. You can see we're configuring enhanced monitoring. We know some of the last steps in creating that instance, and now we're up and available in our secondary region.
Doesn't take very long.
Well, we did use some of the magic of video there to speed that up. So I will.
Okay.
It does take a bit longer than that. Again, very variable depending upon how much data needs to be replicated to that secondary region, the size of the instances that you're trying to create over there. But it is, as simple as the kind of the point and click that you see there in the console. So one of the other things that we definitely want to talk about is some of the metrics you can use to monitor your database. So, and this will go for provisioned Aurora, and there's a few that are particularly tailored for serverless. So RDS Performance Insights, I brought this up before. This is one of the features that's going to require at least 2 Aurora capacity units as your minimum capacity. It's a great dashboard for visualizing database load. You can see SQL weights. You can see how much load is on your CPU. You can see here we have 4 vCPUs provision, and our CPU load is actually below that. So this is a pretty decent example of a well-provisioned database here. So one of the ones that we use for serverless instances is going to be serverless database capacity. So if you're planning on launching a serverless V2 database in the near future, you may want to write this metric down: serverless database capacity. This is one that you want to keep an eye on. This exactly
Serverless database capacity. Got it.
We use this to kind of, this will let you see in real time, and it's the same thing that we used in some of the demos to see what your current capacity is. So you can see in this one, it goes up from about, let's see, what is that, 5 ACUs, scales up to around 18, and then it scales back down. So that's an important metric. Then there's another one called ACU utilization. It sort of gives you the same information, but it gives you it in the form of a percentage. How much of my total capacity am I using? So we go from about 15% capacity all the way up to almost 60% capacity, so around 70% capacity, and then back down. So it's another one. And then CPU utilization. This is one that you'll find on provision and serverless. But it shows you in a percentage how much of your total CPU you're using. So, of course, if you're staying up high around that 100% mark, then it's a good idea to probably provision some more.
Yeah, let's say you hit 120. So you hit 100%, and you have fully capped out your maximum provision or your max capacity at 128. Is there any way to get more? This question's coming directly from the chat.
That's a great question. And as of right now, the answer is no. You will be, if you need more than 128 ACUs, then you will probably want to look more toward some of the provisioned instances for your Aurora cluster.
Got it. Thank you.
Mm-hmm.
And we have about maybe 9-ish minutes left. So
Yeah, I think we're right on target.
Perfect.
So one last metric that you want to look out for is freeable memory. This is important as well. If you start dropping down into those single digits of memory available, it may be time to add some more capacity there. Another feature that's available with serverless v2 is RDS Proxy. I won't go too deep into this, but it is one of the features available. Helps you pool your connections. You can increase your failover times with RDS Proxy. Great feature. And if you're interested in any of those features, definitely talk to your SAs or your account team about how to engage that. But fully compatible with serverless v2. And all right, so yeah, this is probably a lot of questions surrounding, all right, how do I get the serverless v2? And there are a few ways to do that. The easiest way to do it, since again, serverless v2 is really just a new instance type with Aurora, what we can do is just add it to an existing cluster and then fail over to it. So that's kind of what we'll look into, what we'll do here in this demo. So we have a provision cluster, right? We have some DBR5 larges there. We have a writer and a reader in AP South 1C. What we're going to do is just select that cluster. We're going to go over to our actions. We're going to add a reader. And then it's going to be pretty easy to guess. You're going to add a serverless v2 instance there. And this will, you see, just this will be a spot where I actually configure the minimum and maximum ACUs because it is the first v2 instance on this cluster. We'll choose availability zone and we'll go ahead and add that reader. So now we've added that serverless v2 instance into our provision, our once provisioned cluster, right? Well, what if we want to make that serverless instance our writer? So what we'll do is we'll just go ahead and fail over to that instance. Give it just a second here. We'll select that serverless instance. We'll fail over. We will confirm. And just like that, we will be able to see the writer and reader instance swap there.
And while we're waiting for that, I'll go ahead and remind everyone who's watching us live to register for today's training to help you get the $500 in AWS credits. But make sure to do that before July 1st. So you can register, and you know what, actually, I won't even read it. I will make sure that we get a link in the chat. So we'll get a link in the chat because there's going to be a whole lot of stuff. But Jared, I'm sorry for interrupting there.
Totally fine.
The banner here too. So
we're doing great.
It's in the banner, yeah.
It's in the banner.
So as you can see now, we have our cluster with a serverless instance in it. So as simple as that. If you're already on MySQL 8 or Postgres 13 and you want to add a serverless instance, or you want to go full serverless, you can do that, and you can actually switch back and forth because we allow that mixture of serverless and provision instances. So a couple of other options for converting over: fast database cloning, which is something that Dustin talked about before. You can actually make a quick clone of your database, change up your instances in there, and that actually can be, it basically becomes a complete independent cluster where you can mix up serverless v2 instances. That's a great way to actually test on your production data, is creating a fast database clone and then configuring that to do some of your testing. Snapshot restore, which Dustin went over a little bit, and then of course native replication are all options for converting to a serverless v2 cluster. With that, I think we got about 6 minutes left for additional questions, or if we want to provide any more guidance for getting those valuable credits. I appreciate everyone's time. Thank you for listening to me. Again, my name is Jared Persinger. I'm a database specialist solutions architect. Please, especially those SMB Central customers, I'd love to hear from you. I'll see you on a future call. We can talk about serverless all day long.
Yeah, we have about 5 minutes left. So let's see. There were a couple of questions I think we put into a parking lot. So Ooh, here's one. Accessing Lambda requires RDS Proxy.
Accessing from Lambda requires RDS Proxy. No. I can't think of a circumstance in which RDS Proxy would be required from Lambda. So unless someone in the chat disagrees with me, I'm going to give that a no.
Okay. So if you're using AWS Lambda, you can access Amazon Aurora directly from using Serverless v2. Just basically make an API call to retrieve the data.
Yeah, you can use those endpoints. We talked about the cluster endpoint, the reader endpoint, and the custom endpoints. Just put that in your code there. Of course, there's a lot of configuring that you'll need to do on IAM to be able to actually, and that's identity and access management for people that aren't familiar. That just creates the rules and the access policies for service-to-service connections. So yeah, just a little configuring.
Yeah, and thank you for answering that. When would you use RDS Proxy with Lambda? Do you have any recommendations or use cases?
No, I don't have any recommendations for that. Hopefully someone in the chat can save me on that one. RDS Proxy.
No worries. RDS Proxy is really good for making your application or any application that needs to make SQL calls to your database. So you can use RDS Proxy for that. Basically, to get started, you go through a couple steps. Jared demoed it, but we do have some prerequisites. You can use Secrets Manager as part of that as well to be able to store those secrets or maybe even parameter groups. And you know what? I won't even go through the whole thing. We do have a really, really cool blog, and I'll pull that blog, I will put that blog link in the chat for everyone. And here we go. Sorry to put you on the spot, Jared. I apologize there.
Totally fine. Totally fine. Happens all the time.
The joys of live streaming.
Life as a solutions architect. Yeah.
All right, cool. Well, everyone, again, remember, if you are joining us live, if you haven't yet registered, please do so. We have a banner here. Actually, the URL is directly below us right now. You can go to newwithamazonaurora.splashthat.com. I had to read it out loud. There is a link in the chat. And by doing that, you are eligible for a $500 AWS credit. So if you plan on using that for something fun, let us know in the chat. What do you plan on spending that money on? I know for me, it would probably be more building and testing and exploring.
Yeah.
So, yeah.
Yeah, we
Jerry?
playing around with Aurora Serverless for me.
We're trying to figure out how to integrate Aurora Serverless into CloudFormation for you, probably.
That'd be great.
Yeah.
That would be really great.
Yeah. I'll be able to scale up and down my cat picture database. $500 worth.
$500 of cat pictures.
Only 128 terabytes, though. We got to stop you at 128 terabytes.
All right, cool. Jared, thank you so much. And up next, for those who are kind of hanging out and waiting, we do have a couple more presentations throughout the day. So we have Amazon Aurora Cost Optimization with Venkat. I'm going to let him pronounce his name. I'm going to say Venkat. But he will be walking us through discussing cost optimization best practices as it relates to Amazon Aurora. And then immediately after that, how to leverage partners and partner engagement strategy with Bachar. So Jared, thank you for joining us. Really do appreciate it.